Good day everyone, I'm Ruthrrashini Vearsu over here and I will be presenting my research topic on predictive analytics for digital commerce, focusing on how machine learning can be used to analyze sales performance and identify potential risk. This project was developed as a business analytical solution in a TikTok shop-style digital commerce environment. It focused on using machine learning to identify high-performing products and also detect products that may be at risk of sales decline. The study used the TikTok Shop seller performance data set and transformed it into an enriched data set for predictive modeling. This project presents an end-to-end predictive analytics solutions for digital commerce platforms such as TikTok Shop, Shopee, and Lazada. Many sellers today rely on the historical data, which limits their ability to make forward-looking decisions. To address this gap, a datasets of 2,000 product observations with multiple variables including price, click, views, and orders was analyzed. Two prediction targets were developed: high sales performance and sales drop risk. Machine learning models, specifically logistic regression and random forest, were trained and evaluated. The results provide actionable insights to support the product prioritization, pricing strategies, campaign timing, and also overall risk management. Let's look into the business problem and project objective. The main business problem behind this project is that many online sellers already have access to product traffic, campaigns, and sales data, but they still rely mostly on the descriptive dashboard and past reports. This means that important decisions such as advertising budget allocation, stock planning, and campaign timing are often made relatively rather than predictively. The objective of this project were to predict high-performing products, identify products at risk of sales drop, analyze important business drivers, explore time-based and campaign-based patterns, and provide practical recommendations for the sellers. Next, let's look into the methodology. This project used the TikTok Shop seller performance data set obtained from Kaggle. The original data sets continued 2,000 observations and 21 columns. After the data cleaning, pre-processing, and feature engineering, it was transformed into an enriched data set containing 2,000 observations and 46 variables. The final data set included original commerce fields as well as the engineered variables such as funnel ratio, engagement indicators, stock, ratings, campaign timing, and two target variables, which are is high sales and is sales drop. The analytical framework followed a full business analytical workflow. It started with data collections and understanding, then data cleaning, feature engineering, exploratory analysis, pre-processing, model training, model comparison, evaluation, and finally business interpretation. Two supervised learning problems were addressed. The first was high sales prediction, which followed on identify strong performing products. The second was sales drop risk prediction, which focused on identify products that may require earlier interventions. Let's move to results and discussion. Exploratory analysis, product and category patterns. In the exploratory analysis stage, I examine products categories, pricing patterns, and revenue performance. The purpose was to understand which category contribute most to the total revenue and how product level performance differ across the dataset. The analysis shows that electronic was the top category by total revenue. This stage also helped identify the overall distribution of pricing and conversion behavior before moving into predictive modeling. This funnel and business performance variables such as view, clicks, add to cart actions, orders, ad spend, and stock level. These variables are very important because they represent the journey from product exposure to purchase. The analysis also showed that the low stock products had the highest sales drop risk. This is business relevant because it suggests that inventory condition is strongly connected to the performance of sustainability. These slides present time-based and campaign-related findings. The analysis identified Wednesday as the strongest day by average conversion and 11 a.m. as the strongest hours by average conversion. Campaign timing was also analyzed by comparing periods such as morning peak, evening peak, weekend, and off peak. It is important to note that the day of week and hour of day variables were stimulated because the original data set did not contain actual transaction timestamp. Therefore, these findings are used as an academic demonstration of time-based analysis. To strengthen the modeling processes, 6 machine learning algorithms were compared. There are logistic regressions, random forest, decision tree, gradient boosting, k nearest neighbors, and also support vector machines. Since the project had 2 target variables, this results in a total of 12 model runs. This comparison allows the best model to be selected based on the performance rather than assumptions. This slide compares model performance across the 6 algorithm. The models were evaluated using accuracy, precision, recall, F1 score, ROC-AOC, and average position. The results clearly shows that the best model differs depend on the business task. This is important because no single algorithm performs best for every problem. The comparison demonstrates why multiple algorithms should always be tested in business analytic projects. For the high sales prediction task, the champion model was gradient boosting with 1-hot encoding and medium imputations. It achieved an accuracy of 0.966, precision of 0.929, recall of 0.960, and F1 score of 0.944. This means the model was very strong at identifying products that are likely to perform well. From a business predictive perspective, this model can help sellers to decide which product deserves more advertising support, stronger campaign placement, and stock protections, and also content prioritization. For the sales drop prediction task, the champion model was support vector machine with standard scaler. It achieved an accuracy of 0.776, precision of 0.233, recall of 0.698, and an F1 score of 0.349. Although the performance is lower than the high sales task, this is expected because sales drop prediction is more difficult and imbalanced problem. Even so, the model is still useful because it can serve as an early warning system for sellers, helping them to review the product before a bigger decline becomes visible. Model confidence and also diagnostic curves. These slides include ROC curves, precision recall curves, probability distributions, and actual versus predicted class counts. This diagnosis visual help explain the reliability of models beyond simple accuracy. The high sales models show much clearer separation between the two classes, which supports a stronger performance. The sales drop models show a more mixed pattern, which reflects the greater complexity of risk prediction. This is why the F1 score and the recall was especially important in model selections. Let's look into the business recommendations for the sellers. Based on the results, several recommendations were developed. Sellers should prioritize product with strong add-to-cart activity, clicks, review counts, and engagement. Advertising budget should be allocated more carefully towards products showing stronger funnel quality. Low stocks products should be reviewed more closely because they are more associated with sales drop risk. Sellers should also consider campaign timing and use model-generated risk flags as a model of routine performance monitoring. So as the final conclusion of this whole presentation, to conclude, this project shows the predictive analytics can improve decision making in digital commerce by transferring product performance data into useful business insight. This project successfully combined exploratory analysis, feature engineering, 6 model comparison evaluation, and business integration. The final output is not only academically valuable but also practically useful for sellers who wants to move from reactive decision to a data-driven strategy. That's all from my end. Thank you very much for watching this video.